I have a plane flying absolutely horizontally at an altitude of 3 kilometers. So here's my 3 kilometers, because here's the ground. Remember, in mathematics, we have just all these absolutely perfect things. Okay, so it passes over this tracking station. Okay, and the angle of elevation. So I think this is the hardest part. Angle of elevation is from the ground up. So that's what they're talking about, that theta. Oh, but I really want this theta because I want to use this triangle, right? I want to use this triangle, and you know these angles are the same. Okay, so then this is the plane, and so I think, oh, look at that. How fast is the plane traveling? So find dp over dt. And then what else do they give us? When, I see it, when the angle of elevation, when theta is pi over 6. And then here's the tricky part. So they're saying here, the angle of elevation is decreasing at 3 degrees per minute. So d theta over dt is negative 3 degrees. You know you cannot use degrees in calculus, so you must change that to radians. So I'm going to multiply that by pi over 180, and so that gives me negative pi over 60. So that's the d theta over dt. So I'll just write it down here. So d theta over dt is negative pi over 60. All right, so I need an equation that has p and theta and this letter, or this fixed number 3 in there. P and theta, right? So I'm looking at this and I'm thinking tangent of theta is 3 over p. So this is the one that's easier to take the derivative. If I rewrite it as cotangent is 1/3 p. So much easier to take the derivative here. So this gives me negative cosecant squared of theta times d theta over dt, 1/3 dp over dt. Now I'm ready to plug everything in. Whoops, that's a dt. So I plug this in, so I have a negative pi over 6. I'm trying to find dp over dt, so that's a totally legit thing to have there. And then oh, look at that. I get to plug in pi over 6 right there. So I know that cosecant is 1 over sine of pi over 6 all squared. So let's say those two negatives make a positive, so I get a positive pi over 6. You know that's root 3 over 2, so that'd be 2 over root 3 all squared, dp over dt. And so let's see what happens here. If I multiply by 3, well, let me go slow here. So 4 over 3 times pi over 6, and then times a 3. And so what does that give us? That gives us those cancel, so 2 pi over 3 for dp over dt. All right, let's go to the next one. Hold on a second. Is that what I got? No, I did something wrong. I'm looking at my little solutions. Oops. Sine of pi over 6. Oops, sorry about that. Sine of pi over 6 is 1/2. So 1 over 1/2 gives me a 2. So I'm still going to take these two negatives and make a positive. So I get a 4 pi over 6. And then I multiply it by a 3. And then that gives me 12 pi over... Oops, and I put pi over 6 instead of pi over 60. Gosh, I'm making mistakes all over the place. Pi over 60 dp over dt. And so that's a fine answer, or you could say that that's pi over 5. Sorry about that. Okay, so let's move to this last one here. So again, I've got this kite, just like the plane, flying completely horizontally. Beautiful math world. And it's 200 feet above the ground. So that's our nice fixed number. So we are always going to be given a nice fixed number. So there's my 200. And then my kite's flying like this. There's my kite. And they say it's flying at that rate. So dk over dt is 5. So at what rate is the angle, okay, let's be careful, angle between the string and the horizontal? So you can think of it as two different ways. Angle between the string and the horizontal could be here, right? Or it could be here. And we know those are the same. I'm going to use this one because it's in the triangle. So let's see, when 500 feet of string, so I'm going to say when S is equal to 500, and I want to find the d theta over dt. So find the rate the angle is changing. So find d theta over dt. All right. It's important to recognize what letters you want in your equation. I want k and theta and this fixed number. I don't want S in my equation. That's going to be my when information, but I don't want it in my equation to take the derivative of. So if I'm looking at theta and k and s, so that's tangent of theta is 200 over k. And then I'm going to flip that over because it's going to be easier for me to take the derivative. So that'd be 1 over 200 times k. Taking the derivative, negative cosecant squared theta, d theta over dt, 1 over 200. And remember, the derivative of k is just dk over dt. So now let's plug in our information, see what we've got. We're going to plug in dk over dt is 5. So this side I get 5 over 200. Oops, I keep putting the thetas down there. D theta over dt is the denominator, right? Let me write that up here. Negative cosecant squared theta. D theta over dt is equal to 5 over 200. Okay, now I'm going to use my when information, right? So let me make some room here. I want to use my when S is equal to 500. So if I'm going to put 500 in here, so I'll put 500. This is 200. And here's still my angle theta. What is it that I'm trying to find? I want to find cosecant squared. So what is cosecant? Isn't cosecant hypotenuse? Cosecant is hypotenuse over opposite. Wait a minute. Do I have hypotenuse over opposite right here? I do. So if I put in 500 over 200 squared, d theta over dt, and you know this gives us 1 over 40, right? And then if I take this d theta over dt, 1 over 40 times, and this would give us, if we canceled the zeros, I would be multiplying by 4 over 25, and so that would give me negative, hold on a second, yeah, negative 1 over 250. Wow.